Hi students, class 10, concurrency theorems, right? Here we are going to see the concurrency of the points from the vertex of A in a triangle. From one of the vertex, if you draw a line, that is we consider AD. From the vertex B, if you draw another line from the vertex B, if you draw another line, let me take it as E and then C. This point of concurrence is called a concurrency of the triangle, concurrency of the lines, right? A CVN is a line segment that extends from one vertex of the triangle to the opposite side. One vertex, here A is the vertex and B is the another vertex and C is the another vertex. From one vertex of the triangle to the opposite side in the diagram, that is AD is a CVN. This line is called a CVN line from A, as well as we can draw a BE is CVN from B and CF CVN from C. Here we have some special cases, that is the median of a triangle, right? If it is a median, means all the points are concurrent. That concurrency point is called centroid, we know that. So median is a CVN. We can say all the medians are a CVN, and also all the altitude is a CVN. We know that if you draw a line segment, altitude, that if it is a triangle, if you draw the altitude like this point of concurrency in the altitude is called also a CVN. Then if wherever the lines are concurrent, we call this a CVN. And also the angle bisector. If it is an angle bisector of that all the side, then is also called a CVN. That is a special cases. So in median we call this a, all the concurrent point is called a centroid, we call this a G, right? And then altitude we call this a orthocenter H, and then angle bisector of the all the sides is a CVN. Wherever that is the points are concurrent, meet at one place, we call this a concurrent. So these are the special case, median, altitude and angle bisector also called as a CVN. Here we see the CVN's theorem, Siva's theorem, without proof. See the point of concurrence. This point is called a CVN. These lines are concurrent line. Give the statement. So Siva's theorem. Let ABC be the triangle. In a triangle ABC, let DEF are the point on the line BC and CA and AB respectively. Then the CVN, the line AD, BE, CF are concurrent. If it is concurrent, if it meet at one place, all the three lines are meet at only one place. If it is concurrent, if and only if, by the condition we can write the formula, the side BD divided by DC into CE divided by EA into AF divided by FP is equal to 1. All the multiplication of the sides is equal to 1 always by the Siva's theorem. Where the lengths are directed, this also work out for the reciprocal of each of the ratio as a reciprocal of 1. If it is reciprocal, then the reciprocal of 1 is also a 1. Right? The reciprocal of 1 is also a answer, we get 1. If it is reciprocal, all the terms are reciprocal, then 1 divided by 1 is also 1. That is the condition. So in Siva's theorem, all the concurrent lines, all the lines are concurrent, meet at one point, then it is called a Siva's, right? By using this formula, we can able to write this formula is equal to 1. That is BD divided by DC is equal to CE divided by this divided by this and this divided by this and AF divided by PF, right? Is equal to 1. And its reciprocal also 1. Next we see the Menelaus theorem without proof. The Menelaus theorem is, here we have the collinear line. Let's see the statement first. A necessary and sufficient condition for a point PQR. A necessary and sufficient condition for a point PQR on the respective side of BC CA and AB are their extension of a triangle ABC to be collinear. Wherever it is collinear, we use the Menelaus theorem. Suppose it is concurrency, means we use the Chivas theorem. It is collinear. That the formula is, this is the diagram. So ABC is the triangle. Here P, Q are all the 3 points are lies on the same straight line. If all the 3 points are lies on the same straight line, means we call that PQR is a collinear point, collinear line, right? By this condition, we can write the formula, that is BP divided by PC is equal to CQ divided by QA, and then AR divided by RB, right? AR divided by RB is equal to -1. This is the formula for Menelaus theorem, that is BP divided by PC, CQ divided by QA, AR divided by RB is equal to -1, where all the segments in the formula are directed segment. All the segments of the formula are directed. Here we have collinear points. Here we have the collinear line. This is the line. PQR is the collinear line. The condition satisfied collinear means we use the Menelaus theorem. We use the Menelaus theorem. That is the necessary and sufficient condition for a point PQR on the respective side BC, CA and AB of a triangle ABC. Here major triangle is ABC to be collinear is that, then only we apply the formula. This term is equal to -1 is the formula. So let's recall this. Concurrency theorem. Concurrency is always satisfied the CVNs. Here median, altitude and angle bisector are concurrence, right? CVN theorems, we have the formula, that is BD divided by DC is equal to CE divided by AE, and then AR divided by FB is equal to 1, and then its reciprocal is also 1 by the concurrence, point of concurrence, right? For the Menelaus, the necessary and sufficient condition, right? It will be a collinear. The line PQR, ABC is a triangle. One of the line, the point is collinear, means we use the Menelaus theorem. This is the formula for Menelaus theorem. Thank you, students.